Hello, fellow problem solvers. So today we're going to be starting a new series called programming stuff. So in this one, I just saw it right now. You're given two non-empty linked lists representing two non-negative numbers. The digits are stored in reverse order, and your goal is to add the two numbers and return the sum as a linked list. You may assume that two numbers do not contain any leading zeros except the number zero itself. So for example here, this would be like 342 and 465, and when we add them together we get 807. Okay, so there's some carrying going on. We have these three examples, and this I think is an important example here because it shows that we might need to add a 1 sometimes. Interesting. So let's see, what are your first ideas? I invite you to pause for like the next 5 minutes. Put your first ideas out on the computer screen. So the first thing for me was that I wanted to see, okay, what do these list nodes look like? And I printed out one, and I got this. It's a list node. Okay, so it has the value 2, the next one, which is also a list node, and when we're done, we get a none value. So this should be like 2, 4, 3. Okay, so I'm going to be returning also a list node. Now let's see how this will be done. So I guess what I'm doing is, this is my input, and now I'm adding the numbers one by one. And the only time I run into an issue, when I need to carry a 1. So let's maybe write that down. Carry will be 0. And let's see what else we need. So we have a list node. So maybe at this point we can have the answer be just a list node and with a value 0, sure, with the next being none. And then we'll change these things. Okay, so now I think we want to loop over the list nodes, but how long do we want to do this? So let's see. Let's say current index, I'm thinking. So what do we want to do? We want to, let's see, let's just do while true at this point. So what do I want to do? I want to take L1, and I want to get the value of L1. So this is my X is the value of L1. My Y is equal to the value of L2. And then I want to have my next be equal to, is this a keyword? Next node be equal to L1 dot next, and I want my, actually, so let's already do this a bit differently. Actually, let's see, L1, so we have the current. So current 1 will be L1, current 2, second current node will be L2. So this will be current 1 value, current 2 value, and then we'll have current 1 will be current 1 dot next, and current 2 will be equal to current 2 dot next. And we want to continue doing this. What we'll do then is we will have answer dot value will be equal to what? Let's see, what will this be equal? Well, this will be equal to x plus y plus the carry. And then we have answer dot next, right? So what is the answer dot next? Well, it has to be, let's call this current answer node. I do not have a better name. It's going to be answer. And so I'm not really looking at answer dot value. I'll just have, let's see, I'll just put current answer node because I want to return the answers my thinking, and that current answer dot next is going to be, so actually the next one is going to be what? So this is a value. What's the list? So I need to instantiate a list node somewhere, right? Is the value of the next one going to be a list node? That's empty. yes. And I think once I do this, so what I'm doing here is I'm creating a value for the node. So I'm putting in a 7. And then I'm putting in the next. I'm creating this list node. And then what I'm doing is I need to make the current one point to here. So I'll have current answer node is equal to current answer node.next. So now with this, what do we need? What do we have? Oh, we also need to check if x plus y plus carry is greater than 9, then carry is equal to 1, else carry is equal to 0. So we have this thing right here, and it's not going to be a while true. It's going to be a what? What is this going to be? So I think it's definitely while current 1 dot next. And let's make it current 1 dot next and current 2 dot next and see what we get. While both of these have something next, like that's not going to work here in this case, but let's see like what happens when we just run this and then return the answer. I'm just curious at this point, what will happen? And answer is pending. That's not great. Current 1, am I changing it? My answer was 7, 10, and 0. Huh. Oh, I probably did not do this one. But if we change the next to this, and also we need to do what? We need to have this be equal to, well, I think the simplest way is really to just say this. Yeah, we can do that. This minus 10. And now let's see what our answer will be for this input. Yeah, we had an extra 0, which we can delete at the end. I'm fairly happy with this. Let's just do like a custom test case. I want to see what happens when I put in, let's see what happens when I put in a 0 and a 0. Actually, I have no clue what this will give me. I think that no matter what I put in right now, what's going to happen is I'm going to give an extra 0, no matter what. And I think 3, 4. I'll just have an extra 0. Judging, yes, my answer, expected answer, okay. So why am I getting the extra 0? Well, I'm instantiating this. Do I want to fix this now? I think not. But let's think about the order of moves. So while either one of these has the next one, tricky. So what do I want to do? I want to go one by one, like I'm doing this now. But say that there's something else. Actually, here, I invite you to, take this for the next 10 minutes and try to work with it and try to maybe solve this. So one quick way of solving this is because we pick the currents after we just extracted our values. We can say, well, if there is no current, we will break out of this loop. But if there is no current 1 and there's no current, if there's either no current 1 or there's no current 2, then we just and we'll just not instantiate the answer node's next one. And then let's see what happens when we do this. And the results are, yay, I think it's okay. Now we will have a problem when we run this because we are not really adding, wait, what? This is, yeah, this is okay, but then this is strange. Why do I have a carry of 1? This is wild. This is unexpected. So now let's see this. Carry of 1. If x plus y plus carry is... This just bothers me now. So there was a carry of 1. Let's just, before anything, I'll print x, y, and the carry just to see what is happening here. And runtime error because x is referenced before assignment. Yes, that will give you a runtime error. X, y, and carry. It's wild how these bugs show up that you don't really expect. Mastodon 000 013 940. Why do I get a 4? What? Oh, I am assigning this to a 1 before. My God. That is why I get a 4. But okay, we have something happening. So now we need to figure out how to carry on. Carry on my wayward son. And I think there's a couple of ways we can do this. We can now we can see which one of the currents failed. And after we do that, we can, so let's just like, only current is going to be equal to current 1. How do I actually write this? So if current 1, then current is going to be equal to cur 1. Else, I'll say if current 2, current is going to be equal to current 2. Let's just assign currents to none. This might be a bad way of writing this, but hey, it might work. And now if current, so if one of them was assigned, then there's something that needs to happen. And what is that needs to happen? Actually, a while needs to happen. So we will have x is equal to the current value. And then I'll have the current is going to be equal to current.next. And now if x plus carry is greater than 9, then we'll have the current answer node value. We'll just have this exact same thing happening. And let's fix the indentation. We'll have that. And if current is no longer with us, actually, if it is, if current is with us, then we shall add this thing right here. And right now, I don't know if this works or not. Actually, this does not fix the one thing we do need to fix, but it will handle the case with when these things have different sizes, I think. I'm of course not sure, and I'm of course wrong. It did not handle this. Why? This is why mathematics, sometimes, every single step you're taking and you know why you've taken it. Whereas computer science is like, you're sometimes just messing around and you don't know why you've taken a step. Current answer node value is equal to this. And so let's see, x plus carry is going to be equal to 2. So we get here, we get to the current answer node. What happens here is my question. So this fails. And the current answer node is what? Let's just print it. Just see what print current. Oh, I don't know actually what I'm doing. Let's see what current answer node gives us. And this is like a general problem solving thing, like when problem solving in computer science. But what? Oh yes, this is another thing I need to print. Is that you like debugging? Print statements help you debug stuff. Value is free and next is none. Now I'm actually confused. Wait, what? My answer was a 6? How is this? What sort of what thing happened here? This should not be happening. And I guess this is a common thing with computer science. When you're doing coding problems, things happen that should not be happening. Let's just print the answer before we print this. And 4, 3, okay. And then I mess something up and I give us a 6. And what's happening? Oh, maybe I need to do if current. Then I first need to make this. I think this is actually what the problem is. I'll first need this, and let's do this thing now. And I think I'm still getting a 6. Where in the world, like you're, I think it's adding the, I have no clue what it's adding. How is it getting a 6? But I guess it's there. The value is 0 and the next value is none. Interesting stuff, interesting stuff. Definitely interesting stuff. That's what I tell myself when I don't know what's happening. I tell myself, oh, interesting stuff is happening, because then I can, I'll feel better about myself. So the current one is none. Actually, that was just like too much. The current one is none. So what do we need to do? Actually, here I invite you, please, pause for 5-10 minutes and try to work with this or solve the problem yourself. Like, this is literally my thinking. I'm just like thinking, I've solved one part of it. Let me solve, like, divide and conquer. No, I've solved this part where there's nothing to add, and I need to solve this part right here. And I need to solve the part where they have different lengths, basically. And I think that's really what we're trying to do here, solve different lengths. And now I invite you to pause. And here's my bug. There's no y. That's what happens when you copy and you don't think too much. You add a y where there should not be a y. And now what happens when I run the same thing? I pray and I see, yay, it seems like it is working somewhat. So now we need to do the final thing after this is done working, is add a potential 0. But like, who knows? Maybe you need to add a potential 0, maybe not. And that's just to say if carry is 1, then we need to have the current answer node. What do we need for it? We need it to we need to add a 1 to it, really. Current answer node dot next will then be a list node with value 1. I think value equal to 1. I think if we just like value equal to 1, I think that's about solves that. If carry is 1, so the carry shouldn't be 1 here, so this should not change anything, and it doesn't change anything. But let's say this was a 9, and now we see if this logic was correct, and yay, it was correct. And now we clear our print statements, and this might be, I don't want to start off the series with, and here we're done, and then like I just submit or run the exit tests. And actually I've not submitted here for a long time. I don't know how this works. I click submit and submission results accepted. Do I get details? And I think that's our first problem here. And well, this is mildly annoying. Well, I'll say we haven't optimized anything, so I am okay with this. And this solves our problem. And as always, oh, we passed all the test cases. Beautiful. So this solves our problem. And as always, thanks for problem solving.